It's recording.
Why? Every time you see it's a 3, 2, 1.
Oh,
Hey, is it
really?
recording? Is it
Okay.
on?
You're not right.
So the step function is exactly what it sounds like. It is literally a horizontal line that just increases by little steps. So it's like little sections of a step.
Wait, then it's just like.
Yes.
Well, no.
Yep.
No.
Yeah, let me just do it, and then y'all
Yeah.
can see what you. Let's
I know
see
what
how
it
it
is.
works. So step functions.
I'm actually gonna go.
We're going to learn two different ones. One is called the floor. And one is called the ceiling. So I'll do both. I'm going to do the ceiling over here.
Hey, step 4.
Okay, so the function looks like this. It's actually given in a couple of different notations, or it could be written like this, where you have almost like a matrix type of thing around it. Yeah, some of you know matrices and some of you don't. Or these are all the same thing, guys. It's a floor function.
Is that absolute value or is that just?
No, it's not absolute value.
It's a
I'll
L.
tell you in just a
Wait,
second.
what's
Sometimes it looks even like a double, like a little line there. Now, the ceiling function, there's only one that we're going to show you, and it literally has like a little ceiling on it.
Yeah, they both look the same.
See how this has a floor? If you look over here, this one has a ceiling.
Whoa.
This is also referred to as the round up function, and this is also referred to as the round down function.
Wait, these symbols are hard to differentiate.
They are. On today's worksheet, you'll see that they're kind of different. Yes, Carol Ann?
Under the floor function, you have y equals x, and it doesn't have a ceiling, and then y equals x, and it has like a ceiling and a floor.
Yes.
And then below that, isn't that the same thing?
It's a
No, this has a double bracket. Sometimes that has. I tried to show that, but if you missed that, let me kind of show you again.
Wait, so you're just rounding the numbers?
Hold on, I'll show you. But yes. Okay, so that's the best I can do. But you'll typically see one of these top two. The ceiling function is just this one. It's not as common of a function as the floor function is. So let me kind of show you what the data table would look like for one of these. And I'm going to have to give you decimals because that's where the rounding occurs, when you're between two integers. So let me start here and kind of show you something. Now, the first thing I'll show you, so I'm going by half values for x. I'm going by half increments.
Why?
So a -2, because I said that's where the rounding occurs, so I'll have to do in between. Because every integer just gives you the y. So look at what I'm doing here. So see what I did already? So every integer just is the value. So if an x is a -1, then the y is a -1. But it's what happens in between the integers that's important.
-2 for the next one.
Well, what would this be? Very good, because I'm going to round down. And think of it on a number line. You're rounding to the left integer. So you're going down. So this would be -1. This would be 0. This would be 1.
Is this what makes it steppy?
This is what makes it steppy. Yes, very good. So now, how is this going to look? I'm always going to start at the origin with a bubbled in circle because I have a point 0, 0. So what is going on between 0 and 1 for my x's?
It's like
Stays the same.
increasing
It stays at 0, but when I get to 1, it jumps. So this is the relationship and the pattern that we're going to use.
Whoa, what the?
And then down here, this would be open. It goes to the left like this. Open, goes to the left like this. And it continues in that pattern. Open.
So you draw
Okay.
circles.
Yes. It's because at 0, 0, there is a point, and anything between 0 and 1 for x is still at a y of 0. It's rounding down to that y of 0.
So you don't draw it like you don't like this.
No, there's nothing in between the y of 0 and the y of 1. It's literally stepping. You're here, you jump, you step, you jump, you step. This is not continuous in that you would have to like pick up your pencil to trace this. This is not continuous. There's not continuity here for this function.
I thought it would have been just like a straight line.
Oh my god.
A lot of people do, but that's not.
Like domain or
That's why you let her show us.
Yes, I'll show you domain and range and all that in a second. So you start at the origin with your bubble filled in and go to the right. And Caroline, I'll get you in just a second. With this open bubble. Okay? Yes, Caroline, what's your question?
So it would always be like a dot product thing. It's not continuous.
Yeah, pretty much. That's a good way to think of it. Okay? Now, what about the ceiling or the round up function? So let me just do a little data table here. And I'll do the same exact values, -2, -1.5, -1, negative
We round down.
Now you're rounding up for this one.
Oh, didn't we just round up for this one?
No, we rounded down. Because
0.5 would be
0.5 went back down to 0.
So let me do my integers first. So this is the first thing to know, that they are similar in some ways. You have a -2, you have a -1, you have a 0, you have a 1. It's what's happening between is what makes it round up or round down. This is rounding up. So -1.5, you would go to the right on the number line, is going to give you what? -1. Very good. Then -0.5 rounds up to 0. A 0.5 rounds up to 1, and then this rounds up to 2. Okay? So now, we're going to start with the same 0, 0. And you know you also have like all of your bubbles filled in like this. Same thing. This one's different though. You go to the left to open your hole, to open that. You go to the left. And we'll talk about why in just a second. So go to the left. I do not know why my pen is not working. Like this.
Oh wait,
So-
so you're connecting the dots?
I am connecting the dots. Here to here, yes. Because there are values in between.
Oh, okay. I didn't see like.
Oh yeah, I connected them over here too.
Okay.
I didn't
So
know.
anything in between, like -1 and -2, you have to know where is it going. Is it going up or is it going down? For this one, it goes, so -1 to -2 is going to round down to the -2. Over here, anything between -1 and -2 is going to round up to the -1.
Yeah, I guess
That makes sense.
Okay, good. And that's pretty much all we have to do. Now this one, you start at the origin again.
It doesn't really look any different.
Well, this is how it is different.
the side of that.
You start at the origin with your bubble, and you go to the left.
That's important.
Yes, it is important. It makes it one function versus the other. That's the only difference, truly. That is the only difference. So you're going to want to know the symbols that are saying to round down versus round up. And then that's really the main difference, is when you put your initial bubble, like you're filling in that point, 0, 0, are you going to the left for your open bubble, or are you going to the right? Okay, so it's sort of counterintuitive. Like if you are doing a round down, you open your bubble to the right. If you're doing round up, you open your bubble to the left, your open bubble. So let me explain mathematically what all that means. If I have an x between 0 and 1, I'm going to round up to a 1. That's why it's jumping up. Over here, if I have an x between 0 and 1, something bigger than 0, I'm rounding back down to that 0. So I'm staying at 0. Whereas I jump up sooner on the round up. I'm
So,
jumping up sooner.
What makes
So
this go step function?
What makes this what?
Like, I mean, what makes this go to like the floor versus ceiling?
It's just what you're told to do. And it's how the rounding works. It's just whichever way you've been asked to do it. And what application is there for this?
Stairs.
Stairs. Yeah, no. What about pricing? Like if you're shipping something, have you ever noticed, like if you're shipping, say,
Stairs.
1 to 5 items, you may pay $5. If you're shipping 6 to 10 items, you may pay $10, something like that. That would be a step function. So it's like your X would be your number of items, or maybe even the pounds, how much you're shipping. So there's flat fees for different levels of shipping. And y'all probably all have seen that, or at least heard your parents talk about that. That's probably the most applicable thing I can think to tell you. You really don't. We won't have word problems or anything with this. It's just graphing it. Yes, Alton.
So like on the ceiling one, if you had a 0.4, would it go to 1?
If I have on the ceiling 1.4, so think about it like this on the number line, guys. This is always the way you can do it. So if I have a 0.4, do not know why my pen is not working. So I have 0 and I have 1, and 0.4 is right about there. So if it's the round up, I go up to 1. If it's the round down, I go to 0.
So like
That's all you're doing.
So you're like not only rounding the halfway in between, so you're just rounding
Very good question.
anything after
Yes,
that.
and that's what creates that flat line there. I just showed you those, but that's a really good question. So anything between 0, either function, an x of 0 gives you a y of 0. Either function, an x of 1 gives you a y of 1. Either function. It's what's in between as to whether or not you go down or you go up. If you're anything in between, the round down, you go to 0. Anything in between round up, you go to 1. And that's really the gist of it. Okay, now, guess what we get to do with these, though? We get to stretch them, we get to compress them, we get to do domain, range, x-intercept, y-intercept, all that. Okay,
But do we have to?
yes, we want to.
Not really.
Okay, so let me give you an example. So y is equal to x plus 4. Now, y'all, this is one of those things that if you pay attention, you're going to be like, oh, that is really easy.
But if you don't pay attention,
You just step on 4.
Floor function.
How do you know that? It's because you have the 4 there. Now, where has the origin been translated?
Or to the right.
Left.
4 to the left. So I'm moving my bubble here. And since it's a floor, I open to the right. And then I just follow the pattern from there. The whole graph just got shifted forward to the left, and that's it.
this is so
Do we have a ratio? I don't feel like
Okay, so what is the domain? And the range.
Real numbers.
Okay.
Negative.
All real numbers, very good.
Wait, why do we do this?
Why don't you stop?
Why do we translate it?
Yes.
Because we're going to do the same horizontal, vertical translations we always do. This is all integers. Now, this is the part that gets a little tricky. Your x-intercept is actually not a point. What is it?
2 points.
Oh, it's a lot of points.
It's a little interval, yes. And it's going to be, on this problem, it's going to be -4 to -3, including -4, not including -3. And the y-intercept on this one is 0, comma 4.
Yep, that makes sense.
So the y-intercept will always be a point, and there always will be a y-intercept. There's not always an x-intercept.
I don't know why we haven't lost it.
Well, it's because like if you look at where it's all
Yeah.
now we connected.
It's always
Well, that
the
is
same as
one.
the negative infinity.
So like the solid dot, it means that it is included -4.
Say that again,
It's
Alex.
always
Clear dot.
No. Okay, guys, very good question. Is all integers the same as negative infinity to infinity? No. There are no y's that are like 0.5, 0.2, 0.3. There are no y's in between 0, 1, 2. So it jumps. It literally is like jumping the steps. You're jumping the steps. Your y's are going up in a step increment. Your x's are not. It's everything for your x's because they span all the way across your, from negative infinity to infinity. Yes.
Like, does it matter how many you do? Like, could I have done like 4 up and 4 down? Or like,
You need to do, you need to do that many really, and honestly, I'd prefer if you actually finish this off.
So like you hit
no,
the
like throughout the whole
x-intercept,
graph.
y-intercept.
Yeah, pretty much.
Compared to other things where we have like 3 points on the graph and we have to, this like
Not hard. Okay, so let me do another one.
Can you explain the y-intercept?
The y-intercept is this point right here. This one is not actually a point on this graph. It is not in this function. 0, 3, because what happens